Hi, my name is Rob O'Donnell, and today I'm going to be talking to you about a system and process of analysis of shipboard landings. So, first, I'm going to give you a little background on why I chose this topic and why I think it's important to understand this process. Then, I'm going to discuss a cognitive walkthrough I completed, a heuristic review, and then also concept mapping involving an expert and novice in trying to determine any potential gaps in between the way they view the process. So, shipboard landings are some of the most complex and high risk maneuvers that Coast Guard aviators complete. I can personally identify with that as someone that's flown off of a ship considerably throughout my career. It is some of the most dangerous and challenging flying that I've done, and we complete it in all sorts of weather conditions and also different types of illumination, all the way from bright sunny days to complete and absolute darkness. And it's also something that's very hard, in my opinion, to prepare for. The Coast Guard has tried, and they developed a shipboard landing syllabus that's required for all aviators to complete prior to conducting any sort of ship helicopter operations. One interesting thing, and part of the reason why I wanted to look into this, is that the mishap rate is actually slightly higher when operating off a ship. And then when you kind of dive into that aspect of it, it's really high in two specific phases between the takeoff and landing phase. So 95% of our mishaps all occur in those two areas. Very few of our mishaps occur when the helicopter is actually just in a level, or we call it cruise flight. So it's in those two specific phases. So the first thing I did was a cognitive walkthrough. And so I developed a series of questions in order to gain some insight of a shipboard landing process. And so I posed these questions to myself along with two other people so I could kind of develop a thought process on how to get through the task of landing on a ship. So the very first question I asked is, how do you do it? What is the general process of landing on a ship? And then I wanted to get into what people's kind of emotions led them to. Like, what three factors are you concerned about when you're conducting shipboard landings? What kind of positive feedback is available? And how do you know if you're completing this whole process correctly? And then also, how do you detect errors during the process and know that you're not doing things correctly? I also wanted to ask, what are the roles of the air crew? The flying pilot, the safety pilot, and the flight mechanic. What are they all doing during this process? And kind of an interesting question I've always posed to people throughout my career is, what do you think is more important? And I broke it up into instinct or knowledge. And in this case, I think instinct is like proficiency. Like, you understand how the helicopter and how the ship are going to react to different environmental conditions and things like that, based upon your previous experience and based upon recent experience. Vice knowledge, which is manual-based training of how can you regurgitate the process and things like that in order for the process to go well. And so here's the kind of cognitive walkthrough map I derived. And so I broke it up into 4 phases, and this is a really generalized map. And the way I kind of thought about this is, if I gave this to someone that was flying a flight simulator on like Microsoft Word, they would have a general idea how to land on a boat. And the first phase was transitioning from altitude to the surface of the water. And then we have to kind of figure out what we want to do. Are we going to use the flight director or manually fly? And then we're going to descend this helicopter from our altitude all the way down to 50 feet above the water level. So 50 feet over the surface of the water. And then once we're down there, we have better visual cues, or we can use our instruments to control our descent. And then 100 feet prior to our desired altitude, we're going to start to increase our power and arrest our rate of descent. And then lastly, we're going to begin our station keeping phase. And again, just like the transitioning from the altitude to the surface of the water, we have a couple of options. We can use the flight director modes, because we have a hover mode, or we can just manually fly it, which is actually what I'm the most comfortable doing in these situations. Then what we're going to try to do is maintain a position 100 yards after the ship and 50 feet above the water line. From there, we're going to have great visual cues because we're really close to the surface of the water, and then we can also see the ship pretty closely. If we're having a hard time for some reason seeing the surface of the water, then we can use our instruments, our in-flight instruments, to give us a good idea of when to land. But if that's the case, we probably need to land quickly because we put ourselves in a bad situation. The next thing we're going to do is we're going to confirm our landing clearance and determine what the ship motion is, the pitch and roll. So how much is that boat moving around? And then we're going to transition to the flight deck. From here, you have to manually fly it. We have no way to have an automated helicopter land on the ship. And so as we're getting ready to transition to the flight deck, we're going to control our closing speed to the ship because it's all about relative motion. And we're going to use our visual cues on our peripheries, and then also the flight mechanic is going to give us conning commands to help us maintain our position. And again, we're going to just keep using those visual cues and listening to the flight mechanic, and then we're going to position over the landing area. And from there, we're just about ready to land on the flight deck. And we're going to maintain our position over the landing circle. And at this point, the pilot's scanning kind of inside and out to make sure they know where they are. We're going to look for the landing signal it's called the Landing Signal Officer, LSO. We're going to confirm the landing position from the flight mechanic, make sure we're in a good spot, a safe spot to land. And then we're physically going to land. We're going to reduce the power, we're going to eliminate yaw and drift, and we're going to touch down. At that point, once we have all three wheels down and we're in the landing circle, we're going to confirm the talon, which is basically a hydraulic arm that goes and sticks onto the ship, has engaged. And if it hasn't engaged, we're going to signal for primary tie downs. And so some key takeaways after I discussed this cognitive walkthrough with two people. One evaluator had significant experience in the process, and one evaluator that had very little experience. So the first evaluator that had experience in the process felt that the concept map was good for the purpose of just giving someone to land in on a flight simulator, but wasn't necessarily good for Coast Guard aviators because it doesn't show the decision gates between each phase or task. And then the evaluator with little experience, surprisingly, felt completely overwhelmed with all of the tasks and potential subtasks that each task brought, and wasn't really sure where to go from there. Also, both evaluators enjoyed breaking up the process into those 4 phases. They felt like it gave them decision gates and kind of bite-sized options in order to focus for each phase. And then also, both evaluators, who are both Coast Guard aviators, emphasize the importance of an engaged and communicative crew to ensure mission success. So the experienced evaluator who has landed on ships before mentioned how important it was to have that flight mechanic relaying information, but also the safety pilot monitoring and backing up the flying pilot. The evaluator with little experience relayed generally the same message based upon his hoisting experience. So lowering a cable into the water and picking somebody up. That takes a tremendous amount of crew coordination, and so he really understood the importance. So then I completed a heuristic review, and I created 10 heuristics based upon Nielsen's heuristics, and kind of adapted them to kind of Coast Guard specific operations. The first one was a visibility of a system status, and so here I wanted to make sure that the user was sure of where they were in the process. The next is match between the system and the real world, that the user is familiar with the language used, and has a natural flow, that we're not using a lot of really confusing terms. The next is user control and freedom, that the user has control of the process and really has their emergency exit, their ability to get out of a bad situation. The next heuristic is consistency and standards. The process is the same regardless of the landing platform, because in the Coast Guard we have basically 4 different ships that we can land on with the same type of helicopter. So I just wanted to see if people thought that each ship was relatively consistent. And then error prevention. Does the process eliminate errors before they potentially happen? The next heuristic is recognition rather than recall. As aviators, we have a lot of stuff that we already have to memorize, and I think I've given the penguin and iceberg analogy before, but my iceberg can only hold on to so many penguins before some penguins inevitably get kicked off. Flexibility and efficiency of use. The process caters to both experienced and the inexperienced user, which is really important because we always have new pilots that are joining the Coast Guard. The next is aesthetic and minimalist design. Is there minimal communication necessary to transfer critical information, which is very important to me in high-stress situations. Next is help to recognize and recover from error. Are errors displayed in plain language? Are they easy to determine? And then lastly, help in documentation. Documentation is presented in an easy, informative, and concise way to understand. And here's what I came up with, which is really interesting. So again, Evaluator 1, which is the orange/red line, is the less experienced aviator. Never really been to a ship and never worked on a ship or anything like that, but has plenty of flying experience. Evaluator 2, the blue line, is a very experienced aviator. He's been on many ships, different platforms, and has seen his fair share of shipboard landings and takeoffs. And I thought this was pretty interesting. There's definite areas that I think we can improve. The two biggest that jumped out to me was error prevention and help in documentation. And then also some other areas that I thought were a little surprising was recognition rather than recall and consistency of standards. So the first one I'll talk about is help in documentation. I thought that was really interesting because there's a disparity between Evaluator 1 and Evaluator 2. Evaluator 1 felt like there was plenty of help in documentation because we have a ton of manuals. All the information is at our fingertips. Evaluator 2 agreed that the information is at our fingertips, but it's not at our fingertips when we're flying. A lot of things are just written in manuals, and we're expected to know those manuals kind of inside and out. And if we don't know it, we're able to look it up. But unfortunately, you can't really look it up in the helicopter. And I know myself included, I've had to call back to the ship when I've had a problem with a system and needed to basically phone a friend, phone one of my maintenance people on what to do. And so that kind of goes into the recognition rather than recall. And so I thought that made sense that Evaluator 2 rated that a little less because a lot of the information is pure memory. And so although we use a checklist, you have to know what to do on each step of that checklist. And then you have to understand the language and what you're trying to ask for from the ship. Error prevention, I thought that was really interesting because I had agreement between the two evaluators on error prevention. And in this case, neither of them really felt that the process necessarily stops errors, that it's kind of up to the pilot and the aircrew in general to recognize what's happening. And if they see an error, that they're the ones that call it out. And very rarely do people on the ship, from my experience, have called it out. For instance, we had one mishap where a bird flew through the rotor arc and ended up having a bird strike on the helicopter, and people on the ship saw it, unbeknownst to the pilots or the aircrew, and they let the maneuver to continue on. They allowed the helicopter to take off and go on its mission, even though there was potentially damage and significant damage to the helicopter. And that kind of story has resonated throughout the fleet, which is why I think there's kind of a lower rating for there. And then consistency standards. I thought this was another interesting one. Evaluator 1 really understands that Coast Guard aviation is very standardized. We do everything a very specific way, and that's been why we've been very successful in certain environmental disasters. Is we're able to plug and play different aspects of the crew together. Evaluator 2 was slightly less optimistic when it came to shipboard operations, and that's because each ship generally operates slightly different than the next. Although they are operating within the rules, they may do things just slightly different, and so you're not too sure about what to expect when you're arriving on the ship for the very first set of evolutions. It tends to be a bit of a steep learning curve, and it's easier for the three-person helicopter crew to conform to the 150 person ship than the other way around. And so to develop a concept map, I interviewed, again, two H-65 Dolphin pilots, both in the Coast Guard with varying career experiences. Pilot 1, he's an aircraft commander, so he's been flying for just over 4 or so years, has 1,500 flight hours. He's never landed on or worked on a Coast Guard ship, so he has zero shipboard experience. And he's representative of an above-average Coast Guard aviator. He has been selected to be an instructor pilot at the Coast Guard Aviation Training Center in Mobile, Alabama, and he's going to be considered the novice user in this process. Pilot number 2, he's an instructor pilot at Helicopter Interdiction Tactical Squadron, HITRON, in Jacksonville, Florida, has 3,600 flight hours with over 500 shipboard-based flight hours. So he's been operating off of ships quite a bit. He's completed 6 shipboard deployments with over 450 shipboard takeoffs and landings. He's also, he used to be in the Army and did a couple tours of duty in Iraq and flew the H-60. And so he's a very impressive aviator and luckily a good friend of mine. And I am biased, but I would say he's a representative of an above average pilot, and he is going to be the expert user of this process. And so after conducting the interviews and analyzing their answers, I developed concept maps demonstrating their knowledge of the process. And so concept map for pilot number 1. And this is basically what I expected. Just for clarity, I added the 4 different phases just to help kind of break it up and to organize it. With my discussions with pilot number 1, he felt the first thing he needed to do was to set up on a long final, longer than kind of a normal approach in for a landing. He was very specific in saying that he wanted to use a 3-degree glide slope and descend from 300 feet, and then he was going to arrest the rate of descent early to get his power in, and to level off at about 70 feet above the water level, which is just about 25 feet over a flight deck. And then he was going to transition to the station keeping stage. And then he wanted to ask himself some questions before he continued. Do I have the power to continue? The power required? Can I safely conduct this landing? And if he didn't feel that he could, then he was just going to keep station keeping until he felt that he could. Once he felt like he could land, he was going to transition to the flight deck. From there, he was going to control the rate of closure just to make sure he didn't get too fast. He was going to listen to the flight mechanic, make sure that he was in the right position. And then he wanted to know, is the ship pitching and rolling too much? Can he execute this landing safely? And then ready to land on the flight deck. Once he was there, ready to land, he was going to reduce the collective and ensure a firm landing because he wanted to make sure that that helicopter was stuck on there pretty well. Again, he was going to control drift during the descent of the flight deck. That's a pretty typical command for all of us pilots, just to control yaw and drift prior to landing. And then once landing, he was going to request tie downs. So I thought for someone that has never really looked at a manual, I thought this was actually a pretty good job. You could tell he was working through the process and trying to come up with what he thinks would be best based upon his limited knowledge. Pilot number 2, the more experienced pilot, was significantly more in depth. And I won't go through each phase just because it's pretty lengthy. But what you can see here is this diagram is just the transitioning to the water phase, and the yellow circles are all his questions, his um, what information is he searching for, and then the blues the tasks. And so, for instance, on this first phase, the transitioning to the water, he's got two options. He's going to fly it either manually, or he's going to fly it with a flight director and descend down to the surface of the flight director. Some interesting things is you can see he kind of asks yes or no questions, and if the answer is a no, that he tends to go back earlier into the phase and and try to correct things to get back to where he would like to be. And again, here's the second phase, the station keeping behind the ship. Again, he's got 4 specific questions that he was looking for answers to. He can conduct this either manually or with flight director modes. And again, he gave himself exits. For instance, is the ship within landing limits? Up here. Is the ship within landing limits? No. Request the ship to change course and speed. Are they within landing limits after then? And you kind of can get into this loop, which as an aviator can be very frustrating. And then when the ship finally is in landing limits, then you can confirm your landing clearance and then monitor the ship for motion. And then transitioning to the flight deck. Again, more of the same. And so just to go through, we'll go through this one a little quickly. Monitor the ship's motion, and then if you're using the flight director modes, then it's time to disengage those modes and fly manually. And then now he's kind of looking at a question. Do I understand what the sea state is doing? No. Then that means he's going to sit there and study the sea state until he does understand. And when he finally does, he's going to increase his forward cyclic, which is the stick, to gain forward airspeed, and use his collective to maintain altitude. And lastly, use pedals to maintain heading. And again, using that cyclic to control the airspeed, because it's really hard to control your rate of closure if you're not careful. And then another question, is the flight deck clear for landing? No. Then he's going to abort the transition and go back to station keeping until it is ready, and then go through that whole process again. Is the flight deck, if it is clear, then he's going to continue to transition to the flight deck, listening to the flight mechanics commands. Am I clear over the fantail, which is the most aft portion of the ship? No. Then I'm just going to keep coming back and listening to the flight mechanic, and he's going to get me in the right spot. When I am clear, I'm going to continue to transition to the flight deck. Am I clear over the edge of the flight deck? Yes, I am clear. Am I clear over the landing circle? Yes, I am. And did the LSO give me the signal to land? Nope, they haven't. And so that means he's going to abort the whole process again and restart at station keeping and come all the way back up. If the LSO did give him the signal to land, then he's going to prepare for landing. And to prepare for landing, it's actually one of the more simple phases, but it's one of the probably the most dangerous phases, because as the pilot number 2 kind of mapped out, you're more or less committed when you get to a certain spot. So he's going to prepare for landing. Is the ship stable? Yes, it is. Am I comfortable with landing? Nope, I'm not. He wasn't comfortable, and so he goes back to abort the landing and goes all the way back to station keeping to repeat the process. If he was comfortable, then he's going to reduce collective, eliminate yaw drift while landing. Once landing, signal for those primary tie downs, and then consider maneuver complete. So you can see there is a large disparity between the evaluator or Pilot 1 and Pilot 2 for the concept mapping. The biggest The largest and most obvious difference between the two concept maps was the difference in detail between the two users. Pilot 1 didn't have a lot of detail, which again I think is completely expected and understandable. While Pilot 2 offered many more decision gates and offered multiple ways to conduct the operation. Pilot 2 also attempted to identify potential problems based upon experience with a faulty flight director, which you saw in the descending to the surface of the water phase. He had a lot of options to kind of get away from the flight director. Pilot 2 also expressed that a lot of his actions were based upon feel and control feedback, how the helicopter was physically reacting in different conditions. And then, kind of funny enough, as a testament to Pilot 1's professionalism, he grew increasingly frustrated by not knowing the answers to the questions, and then would end up kind of poking and prodding me for what the answers were. After our conversation was over, he called me up a couple days later and explained some of the questions that he had. And he went back and studied the manuals and got some of the answers because he just wanted to know. And so, like I said before, the Coast Guard has a syllabus, and the Coast Guard developed a syllabus to train their aviators to conduct shipboard helicopter operations. The syllabus is broken into 4 distinct parts: a ground phase, daytime landings, nighttime landings, and night vision goggle landings, NVGs. And so here I'm just going to go through my syllabus. So this is the actual document that I used and got some feedback on. That was kind of the guiding principle that gave me the sign off to go land on ships. And so here, this first page, this is the shipboard landing ground syllabus, and basically it's just a sit down with an instructor pilot, and you just talk. So I was expected to know all these different terms and procedures, and discuss it at length. It's kind of a quiz, going line by line. And again, here's the second page of it. So this is basically just all the manual book knowledge that we're required to know. Some of it is more useful than other aspects of it, and honestly, some the one and only time I've talked about it and used that knowledge was for this ground phase. And then here's just an example of our day landings. As you can see, I only conducted 15 touch and goes. So 15 landings on the ship. And at that point, I was day landing complete and ready to go to the next phase. And here's night landings. And so we, again, just kind of discussed a couple of things prior to flying. And then I completed 8 night landings. So at this point, I've done 23 landings in my Coast Guard career. And now I am night landing qualified. And then here we go. This is the last phase, the night vision goggle shipboard syllabus. And again, this was another about 8 landings. So in order to be qualified, I've completed just about 30 landings, and then I am good to go land on ships. One thing I want to draw your attention to here was this number, this 13.9. So this is saying in the last 6 months, I only had 14 hours of physically using night vision goggles before landing on some of the most complex and dynamic environments that I can. So I would argue to say that my proficiency was not great entering this syllabus. And so looking at that syllabus and looking at the concept mapping, I did feel that the syllabus did a fairly good job for terminology. Like, I knew what I was getting myself into. I knew what red deck and green deck meant, which are indicators on if we can land or not. And then even just the basics, like port, starboard, bow, stern, aft. You discuss all of those things. So things that People that have never really been on a ship before and they've only been flying, they would get a good knowledge. The syllabus also did a good job of showing the process of just kind of saying, you're going to ask for this through the checklist and just going through the checklist and showing the methodology of a shipboard landing. The one thing I noticed is that the syllabus doesn't really help to control bias or non-standard ship helicopter operations, which I mentioned earlier. That each ship does things a little differently, and unfortunately, when you learn bad habits early, they kind of stick. And I've noticed that just in myself, and then with other pilots that I've flown to, and you can trace it all the way back to the very first time that they took off and landed on a ship. The syllabus does not explain technique or preferred methodology, and that's meaning of it doesn't tell the instructor how to necessarily teach the process of landing on a ship. For instance, pilot number one, he wanted to land really firmly and make sure that that helicopter was planted on that flight deck. Whereas for myself, I tend to try to land really softly because I'm worried about breaking the helicopter or breaking the ship, or really not feeling in complete control of the evolution. And as I've talked to my peers throughout the years, we each have a slightly different way of how we operate, even how high we initially climb off the side of the ship during our takeoff. The syllabus, surprisingly, does not discuss risk management or areas of increased mishap potential. How to determine those potential errors. And the syllabus doesn't stress the importance of control touch, and for lack of a better term, the seat of the pants flying. And what I mean by the seat of the pants is just the sensation of how the helicopter is reacting in different areas. Each ship has a very unique signature and presents its own turbulence. And with experience, you can kind of determine how the helicopter is going to react when we call getting into the pocket of the ship, so behind the superstructure, and just getting that feeling coming up through the helicopter to know exactly what forces are being exerted on the machine. And so some recommendations that I came up with are as follows. The first thing and the biggest thing that I can concede is conducting shipboard training operations are costly, time-consuming, and require the concentration of nearly 100 people. It's literally an all-hands-on-deck evolution, and it takes everybody on that ship to be focused on aviators, which as an aviator, we do love the attention. So we like to do ship helo operations as often and as much as possible. First, recommendation number one is just to reduce the memory requirements from the ground syllabus. We can go through and kind of take out some of those items that I haven't discussed since really being shipboard qualified. It may be important in some instances, but we would argue that you'd have time to kind of study. And so as long as you know where that information is and how to get to it, and it's not information that's necessary for in the aircraft, we can probably push that to a different time, or produce a quick aid to put in a pocket checklist. Two, include specific discussions of risk mitigation and risk management while conducting shipboard operations. I feel like this is really important, and this could really help out like the heuristic for determining error. I think by having these discussions and how to mitigate the risk, especially during the takeoff and landing phase, we could reduce kind of that mishap potential. And then three, which I really feel is something that is easily attainable, is to develop a shipboard landing simulator training to be administered during an aviator's required annual proficiency course. So every year, Coast Guard pilots go down to Mobile, Alabama, and we do simulator training on emergencies, and basically we do all the things that we can't do while actually flying. So kind of like crash landings, simulating that the whole helicopter's on fire, things like that. We do have the capability of landing on ships because I know I've done it on there a few times, and it may be worthwhile to have every aviator that is potentially going to be going on to ship is to go through the whole process there, and to really kind of get the site pictures narrowed down and get some shipboard practice well in advance of actually physically landing on our ship when we're um, using the time and the people uh, that are currently working on the ship. And so now that we've kind of talked through the whole process, I figured I would just kind of show you what it looks like. And so here's a helicopter that's landing on a 270-foot cutter. So this is one of the largest flight decks we have, and it's a fairly benign day. It's um, the ship's not rolling too much, and it's really sunny. And so here the pilot, he's looking at all those visual cues and driving it straight in to make a perfect center line landing, and really listening to all those commands that the flight mechanic is giving. And that's it. So I hope you enjoyed this. I hope I was able to give you a little bit of insight on what I felt is important, and I hope you have a good rest of your day. All right, thank you.